Good evening, students. Today we will be discussing on the topic RSA algorithm. So, it's a very vast topic, but it's better if you understand the basic first, then we'll see. Okay, I believe you know, like RSA algorithm is, one of the asymmetric key encryption algorithm. So, basically, how this name came, it's like there were involved three scientists who invented this algorithm. So I'm not going into detail. So let's see one example. So it's very simple example I have taken so that you will get an idea how the algorithm works. So I believe you know what is an asymmetric algorithm. Key, which is nothing but it's a combination of public key and private key. So symmetric, I believe you know that. Like same key, we are used for encryption as well as decryption. But in RSA, I have written here there will be two keys and public key we will be using for encryption and private we will be using for decryption. So we'll take a very simple message. So based on that, how we are going to do the encryption and decryption. And also one more point you need to keep in the mind in RSA algorithm. Here, whenever we try to do this algorithm, mostly we are dealing with prime numbers. Okay. So we'll see the step one. Okay, likewise, how it has been working. So step one, it is nothing but we need two keys. Okay, I already told you for encrypting, we are using public keys. Like I will be giving you a key to lock the door. But in order to unlock it, it's like something that we are giving to the another person. That only one person will be responsible for unlocking. Okay, so the first and foremost, we need key generation, which is being used by everyone. The same explain, the same example I'm giving. If I'm giving you a key, you have the responsibility to lock it or you have the authority to lock it. But unlocking is a mechanism that I can only do it. Okay, the owner can only do it. So here I'm going to take two numbers. Okay, and I'm going to name it as P and Q. And I already told you we are going to deal with prime numbers. So the two numbers that I'm going to use it is 3 and 11. Okay, because both of them are primary, prime numbers. So I will tell you why and all, like why are we requiring this P and 11. Then we need to compute. Okay, we like if I want to encrypt a message, I need the help of this particular value of P as well as Q along with N. Okay, so I'm going to name it as N. So N it is nothing but the product of P and Q. So you know what is a product, isn't it? Product, it is nothing but multiplication. So I got 33 as a result and keep it aside. Now I'm going to compute Euler's torsion. So basically it's a mathematical, a formula. And why are we studying this Euler's torsion? Because uh, I wanted to find a coprime. So I believe you know what is the term GCD. Okay, greatest common divisor. So if I take 2 and 4, like if I divide by 2, I should be getting 2 because I can divide the 2 with 2 as well as 4 also I can divide it. So basically a greatest common divisor will be there. And if I take 8 and 7, we don't have anything because we can't divide it with a common divisor. So the GCD will be 1. So likewise here what Euler torsion is telling, even if I take numbers, I should not be getting any common divisor. So for that, like for example, if I'm taking 7 and 8, I should not be getting any common divisor. So when I say I should not be getting, my result should always be 1. That's it. So in order to compute this separately, for example, I have P and Q. The P's values was 3 and Q values was 11. So I want to find all the numbers like which is coming before 3. Okay, if I'm taking P, the value of P was 3. So before the numbers which are coming before 3 is 1 and 2. So I need to find, whether 1 and 3 is having a common divisor, 2 and 3 is having a common divisor. Likewise, I need to check one by one. So instead of that is a time wasting process, time consuming process. So there is a formula for that. It is nothing but P minus 1 into Q minus 1. That's it. We will get the total count, which means there were 20 combinations were there, which is coprime. That's it. So instead of finding everything one by one, we are using a simple formula. That's it. So basically, Euler's torsion, we are using a symbol. The symbol is what we call it as phi. Okay, phi of n. Okay, phi, phi of n. I have written here. So the only thing you need to understand, I want to find coprime here. So when I say coprime, we have to find all the combinations among the numbers before this P and Q, and we need to find how many are there. That's it. So for that easy process, we are using a formula. So we just have a recap session. So first of all, we have taken two numbers. I have taken 3 and 11. So I have named it as P and Q. After that, I have computed N, okay, which is nothing but taking the product among the P and Q. Then step 3, I computed the Euler's torsion. It is nothing but I have found it that 20 combinations were there, which is 4 prime. Next one is choose a public key. Now I'm ready to find the value for public key. So it's very simple. If I wanted to get a public key E, there are two conditions. I have to undergo two conditions. The first condition, it's like we are selecting a number for public key. Okay. Now stands for encryption and simply naming it as a public key as E. Okay. Don't get confused. So first condition is it should always be lesser than 1 and lesser than 5 of n. Just now we have founded the value of 5 of n, which is 20. So they are telling that even if you're taking the value of E, it should be less than 1. Sorry, it should be greater than 1 and it should be less than 20. That is the first condition. Second thing is that even though if you get a number, that number plus the value of 5 of n should be coprime. So again, this coprime thing is coming again and again. So when I say coprime, it is nothing but the GCD among them should always be 1. So I have chosen 3. And why? Because 3 is lesser than 1. Okay, I have randomly taken, okay. And it is satisfying my first condition and 3 is lesser than 20. Second condition is like, if I take 3 and if you find the GCD among 3 and 20, we don't have any common, divisor. So obviously we can take 3 as a public key because it's coprime actually, isn't it? So that's why there are other numbers. If you take 7 also, 7 is eligible. Why? Because 7 is greater than 1 and if you take the GCD among 7 and 20, of course we will get coprime. So I'm going with a lesser number so that mathematical things and stuffs and all will be easy for you. So I'm taking the value of E is equal to 3. Now what I got the value of public key and I have named it E as 3. Now the second thing is I wanted to find the private key because I already told you public key I'm going to encrypt and private key something which enables me to decrypt it. So I'm going to name it as D. Now how we will get D? So there is a formula and this is the formula. This is nothing but D. I'm going to name it as private key multiply with E. E stands for our public key which we already got. The value was 3. This 3 symbols, this 3 lines, it is nothing but we call it as a congruent. Okay. Double equals to it is nothing but equals. This triple lines, it is nothing but congruent to 1. They are telling by taking the mode of 5 of n. So it's nothing but I will show you. We are going to substitute the value so you will get a clear idea. They are telling D we are almost going to find the value of E was 3, which is congruent to 1. Mode of 5 of n is 20. Now what they are telling is, see, if I take D is equal to 7, I'm just having a hunch that if I take 7 and 3, if I multiply with 7 and 3, it is nothing but 21, isn't it? Now, if I divide this 21 by 20, obviously I will get the remainder as 1. This 1 that you are seeing in the formula now, that is 1, isn't it? That is something, but I should be getting the remainder. What they are telling me through this definition, the remainder, whatever remainder I should be getting, it should be 1. That is why congruent, it has been written as congruent to 1. So whatever value that I'm getting, mode, I believe you know what is a mode. It is nothing but finding the remainder. So if I'm getting the remainder, it should be congruent to 1, which has been there in the formula. So here 7 is perfect example because if I multiply 7 into 3, I will get 21. Now, have you seen that mode 20, isn't it? It is nothing but we have to find the remainder. So if I divide the 21 by 20, of course, obviously I will get 1. which means that is obviously congruent to 1. So we have concluded that 7 is the perfect number for private key. Moving on to next one. So we got two keys, which is nothing but encryption and decryption. So public key was 3 and private key was 7. And this is the formula that we have because we need n also. And we have already been, found it, which was the multiplication of p and q. Now we'll do the encryption first, then I will show you how to decrypt it. So this is the formula of encryption, which is nothing but C stands for ciphertext is equal to M stands for message raised to E mode N. Mode will always be reminder. Keep that in mind. I believe you know that. So I'm going to take my plain text as 4. Okay, I'm going to encrypt my message as 4. Here I'm taking a number. So 4 was my actual message. How I'm going to encrypt it? Nothing, just substitute it. So C was ciphertext. So C is equal to 4 raised to E already you know, which is nothing but 3 and mode N. The value of N was the product of P and Q. We already have that 33. Find it. So 4 raised to 3. Okay. 4 raised to 3, you will get 64. And 64, if you divide it by 33, you will get 31. So when I say node, it is nothing but find its remainder. Okay, so 4 into 4 into 4, I got a result. Divide that result with 33, so you get 31 as an answer. That 31 is the remainder that you are getting. That remainder, you are going to take it as a ciphertext. So instead of passing 4, what we are actually passing? We are passing the value of 31. That's it. Now how to decrypt it. So encryption is done. Now decryption is just in opposite. So this is the formula. Message M stands for message is equal to C raised to D mode N. C stands for ciphertext and D stands for the private key and N is the product of P and Q. Just substitute. So because ciphertext is what we got just now, which was 31. 31 raised to 7 was the private key value. And mode 33. So 31 into 31 will go with 7 times. You will get an answer. That answer will be a long stream. Okay. If you divide by 33, you will get the remainder as 4. And hence we got the the plain text, whatever we have given. Okay. So the original message was being recovered as 4. So that's all about RSA. So RSA algorithm, when you are studying, when you are going with the RSA algorithm, it's better if you start with the basic one. So with that, you will be able to write the working or the algorithm. Okay, so it's very simple. The first thing you need to identify, like what do you mean by asymmetric algorithm and what's the relevance of public and private key and how we are generating this public and private key. So there are few formulas are there and Euler's torsion is very important because here we are in majority we are using the private, the prime number concept and the co-prime. So I already told you what's a co-prime. It is nothing but when you take a combination of two numbers, the GCD should always be 1. That's it. So that's all about RSA algorithm. So we'll wind up with the session. So thank you so much, guys.